Today's topic is rotations. This is the last transformation in the coordinate plane, and you can use a date of June 1st. Our note packet has 4 pages today. You might also want to grab a straight edge or a ruler so that we can make our graphs look nice. All right, when you perform a rotation, what you're doing is taking a figure, you're spinning the figure, but it's also rotating around a center of rotation, which is a fixed point. In my picture here, the triangle in blue has been rotated to become the triangle in red. We can see that A was on the left-hand side and now it's down on the bottom. So the object itself is turning. Think about the Earth spinning on its axis. If you were to draw a ray from the center of rotation, which is located right here, to corresponding positions like A and A prime, you would be able to calculate the angle of rotation. In our picture, they're turning the figure 120 degrees. We're going to stick with more common rotations of 90 degrees and 180 degrees. We abbreviate a rotation with a capital R. Remember, a reflection is a lowercase r. And in subscript, we'll put down the number of degrees we wish to turn our object. Remember, not all rotations need to occur around the origin. So if you're going to rotate around another location, in this example, point A, you would state the center of rotation. This could also be an ordered pair. And then you would state the number of degrees in the rotation. In math, rotations will be counterclockwise unless they tell you otherwise. So the notation should indicate which direction our object is turning. So be careful with the details of your rotation. We're going to start with a 90-degree counterclockwise rotation, which is turning it in the normal direction. Counterclockwise means we're moving against the hands of the clock. Essentially, we're turning the object to the left. You can see in my diagram, I started with my triangle in quadrant 1. This figure moved to the left. It turned in the hands against the clock, and it became the figure in red. We can also see that B was the top of the triangle. Now it's on the left-hand side. So the triangle itself is turning, but it also appears that it's anchored at the origin. If I drew rays from A to the origin and then to A prime, you can tell that that is a 90-degree angle. So this is the fixed point. Think of it as the sun in the universe, and the object is the Earth. So the Earth is spinning as it also rotates around the sun. Because counterclockwise is our normal direction, it'll be abbreviated as a positive 90. So we have a generic rule that will work for all counterclockwise rotations of 90 degrees. We'll take our generic point P. It will map itself to P prime. We're going to move the y coordinate forward and negate it, and then we're going to slide the x coordinate back. So in example number 1, we're going to plot our 4 points, A, B, C, D. And you can see that it's a rectangle. Make sure you draw with a ruler or a straight edge and you label all the vertices. Rotating 90 degrees is counterclockwise, so we're going to apply our rule. We're going to slide y forward and negate it, and then just slide x back. So there's A prime, B prime, C prime, and D prime. Now that we've applied the rule and we know the location of the prime image, we can go ahead and graph it. And if you keep in mind, we're turning this against the clock, so we're making a turn to the left. And there's my prime image. We can also rotate 90 degrees clockwise. So clockwise would indicate that I'm moving in the same direction as the hands of the clock, otherwise known as turning to the right. So we started with our original image in quadrant 1. And when we rotate it 90 degrees clockwise, it ends up in quadrant 4. And again, the object is still spinning. B was on top, now it's over on the right. But you notice it's still anchored to the origin. And if I were to draw rays to A and A prime, I would see that there's a 90-degree angle there. Because clockwise is not the normal direction, the abbreviation will show you negative 90 degrees. Negative 90 does tell me it's clockwise. Basically, it's the wrong way. There is a general rule for 90 degrees clockwise. We'll take our generic point P. It will map itself to P prime. We're still going to slide Y forward, but we're going to leave it alone. When we slide X back, we're going to negate it. So let's try it on example 2. This four-sided figure is the same as the last example. So there's my original rectangle. Now, if I'm turning it in the same direction as the clock, it should end up in quadrant 2. It should go up. So let's apply our rule. So what we're doing is sliding Y forward, and then we're negating X and sending it back. So we'll do the same for B prime, C prime, and D prime. And I'll plot that set of points and label everything, and it does end up in quadrant 2. And again, you can see that the original figure was in a portrait mode, and now when it's turned, it's in a landscape mode. DA was on top on the original, it's now on the right-hand side. So the object is spinning. We can also rotate 180 degrees. We've actually performed 180-degree rotations, but they were called a point reflection through the origin. So this rule will remain the same. There's no positive or negative 180. It's going to end up in the same spot no matter which direction you travel. So we typically tend to stick with a positive 180. And the rule just says you're going to negate X and negate Y, and that will put it in its new location. Because this is such a simple rule, I said that the use of the grid is optional. So we can just use the white space. Let's list our 4 original points. We're going to apply a rule of rotate 180 degrees. And we're going to negate all of our points. And there it is. When we're done with each of our examples, you can see under rotation, the pre-image and the image are congruent. They're the same shape, they're the same size. So rotations do preserve distance between points, and they can be classified as a rigid motion or an isometry. Tonight's homework is 129. Please note that 5 through 10 and number 29 require full mappings. Please write the original points with the rule and the arrows and then its new location. If you have any questions going through this assignment, please make sure you contact me. Otherwise, have a great day.